What we're going to do is we're going to create some global state, and that global state is going to track conversations that are occurring among multiple different users across multiple different channels, and we want each one of those conversational units to be able to track where we are in the hello, how are you, goodbye phase of a conversation. So how are we going to do this? This is really going to get dicey. But we'll start with the simple pieces that we know. We'll, of course, create a client with some intents. And by the way, my general guidance whenever you're working with an API that you haven't worked with before is it can be pretty good practice to just kind of start writing this code from scratch, be very minimal about how much you cut and paste. Just kind of write this code from scratch a couple of times over and over. Gives you some familiarity with just the mechanics of this. Let's run our event loop here. Let's create an event. It has to be asynchronous. We'll get a message, and we'll just print out the message content here. So this is our most basic starting point. Of course, we have to give this the Discord token from Environ or from OS. We'll get there. Here we go. And maybe we'll mark when we're ready. It's always nice to see that on ready message. So here, we'll add that in there just for the sake of it. Okay. So every time we get a message that's from somebody who's not us, so we'll say if message.author is not the client user, what we want to do is we want to track that conversation so we can respond to it. Well, this actually ends up being a very good use case for, say, a generator coroutine. Because what you can think is that a generator coroutine represents a stateful entity which linearizes the control flow and the data flow. It doesn't require that we do something like this. Conversations equals a dictionary, and this maps, or maybe this is a default dictionary. And this maps to maybe our initial state. Then we have to do something like say, okay, conversations for the message author, state equals this. If state equals init state, then you transition the state. Now you could do this equals hello state. Otherwise, we do something like this, and then we send something in response and so forth and so on. Well, this is going to get very, very clumsy very quickly, and moving data between these individual states is also going to get extremely clumsy. So what we might intuitively think to do is make this not just a generator coroutine. Well, we might make it some kind of coroutine with the lowercase c, some kind of generator coroutine with lowercase c. So we'll start with that starting point. Here, what that means is we'll make this a thing that we can send data into. So let's do a simple next on that. Well, actually, that's interesting because we don't know if we've just started the conversation or not. So next here, but we'll just keep it real simple to start with. And then we'll send in the message that we were given. And then here, we'll say, this is the message that we're going to reply to. So here, this gives us a starting point. Once that's ready to go, we'll go back to our server and we'll say, hello. And of course, here we'll need to add just one more step here just so that we don't hit a field. So there you go. We were able to put this into that coroutine, and we should be able to, every step along the way, let's do something like this. Let's actually put this into a infinite loop, and we'll just track which step we are in the conversation. So there we go. So now we can track which step we are in the conversation. So if we say, hello, how are you? And let's check one thing. That's good. We have to send in the message. So the next message, well, it's kind of tricky because we only do that next on the very first step. And we can't send something into this thing on the very first step because we get the can't send a non-none value to a just started generator problem. So what we might end up having to do is some kind of pumping. And relatively easy to do with this regular generator coroutine. Here, we're just going to use our very familiar pumping mechanism. So what this is going to do is this is going to take the coroutine with the lowercase c, of course, and create a coroutine instance and advance past that first step on our behalf. So then we can basically just grab the state of the conversation out of this global dictionary and then send whatever the message is and track which step we're in. And you can see here we're in step 0, 1, 2. So we could do something like that. This is the general idea. And in the body of this, we can basically encode our control flow. We could say, okay, if the message or while the message doesn't equal hello, maybe we don't do anything. Just ask for the next message. And then once we get that hello message, then we say hello back and so forth and so on. The problem is we got to say hello back. How do we say hello back? Well, we're going to have to reply to this message. So if until the message is hello, we'll just keep gathering messages. And at this point, we know the message is a hello. So let's reply to this message with hello to you. The problem is this here requires the event loop because it needs to send a WebSocket message. And because it requires the event loop, if we say hello here, we should actually get to this state here, but nothing's going to be sent back because this has not actually been scheduled to be sent back. So we'll have to await this. But the moment we await this, this thing needs to become asynchronous. So it's not a standard generator coroutine that we need to work with. It is an asynchronous generator coroutine that we have to work with. And the moment we make this asynchronous, well, we're in trouble because our standard pumping mechanism is very unlikely to work. What we'll see when we try to send a message here is, we can't pump this as though this is non-asynchronous. So it's incumbent upon us to figure out how do we pump an asynchronous generator coroutine, which ends up being a very, very tricky problem. Well, here we can sidestep the problem, but before we do that, I do want to take a moment to just remind you of one or two basics of how these things work. Because even reasoning about how this asynchronous generator coroutine works can be a little bit tricky. So as just a tiny amount of background, let me remind you, whenever in Python we see something like this, behind the scenes, what it does is the following. It takes whatever iterable we have and it constructs an iterator from that iterable. It loops forever and it repeatedly tries to get out of that iterable the next element. And if in attempting to get the next element, it receives a stop iteration, well, it says, okay, there's nothing more, and it breaks out of this loop. We see an asynchronous generator. Let's see how that works. So here, we'll do something like this. Maybe we'll say for x in range 3, and we'll yield x. And here, we might say, okay, how do we actually get these values out? Well, is it like this? No, because then what's the difference between this structure here and a non-asynchronous structure here? It's actually the case that we have to do an async for. So let's run this. And there we go. How do we decompose the async for? Well, it's largely the same general idea. Here, we'll create this instance. We'll loop forever. We'll call a next, which is a new top-level function that we have on this. And we'll accept a stop async iteration and break out of the loop. Now, we have to do one more thing here. We have to await this a next. There we go. Of course, we have to await the a next because fundamentally this is an asynchronous generator. That is to say, whatever it's yielding out could be the consequence of something that itself was asynchronous. For example, this might need to await some data loading from a file, from a socket, whatever the case may be, before it can give you this value. So you need to await this so that that scheduling passes down to here. Well,